As we continue to work with simplifying rational algebraic expressions, the first method of simplification we're going to use is based on the law of exponents. So looking at this example of m to the 11th over m to the 5th, we're aware that there's probably some canceling going on. I hope that we're thinking this is all a product. This is like an m times an m times an m times an m, blah, 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 all over 5 m's, right? Now, what I just exemplified here was m to the 4th over m squared. And as you can see, if I cancel my m's, because this is all products, because exponents are repeated multiplications, that I am left with just 2 m's. So m to the 4th over m squared is just going to end up being m squared, which leads me to think, okay, so am I subtracting these exponents or am I dividing them? So maybe let's develop a different example so that I can prove this to myself. So let's say I have m to the 5th, and I divide that by m squared. So I'm going to cancel out 2 m's, and I will get m to the 3rd, which is leading me to observe that what I do is I take my numerator and I subtract my denominator. So based on that, now that I've given myself an example that I can rely on, let's look at m to the 11th over m to the 5th. And using my knowledge of what I established, that's going to be m to the 6th. And so what this is it's building off of our knowledge of the laws of exponents, which is x times a, x to the a, times x to the b is going to equal x to the a plus b. So that means if we're undoing that, rather than using multiplication, if we use division, then x to the b over x to the a is going to equal x to the b minus a. Hopefully you're wondering, though, what would happen if you had m to the 7th over m to the 10th? That would be, according to this formula here, that would be m to the -3. And looking at this and using our knowledge and technique up here, don't we really think that m to the 7th over m to the 10th is going to equal m1 over m to the 3rd? And yes, both of these answers are true. 1 over m to the 3rd is the same thing as m to the -3. Now we're going to learn a little bit more about negative exponents, but this will be just laying some breadcrumbs, so we're aware of that. Now, how could you figure that out on your own? Heavens, no, I don't want you to memorize that, but one thing you could think is, okay, well, if I get like m to the 11th over m to the 15th, how am I supposed to know what that is? Well, why don't you just step to the side and think, okay, well, m to the 5th over, well, let's go m to the 2nd over m to the 6th. That's a reasonable amount of m's to write out. Okay, so I'd cancel, and then I'd end up getting m to the 4th. So that's 1 over, though, m to the 4th. Because look, my m to the 4th is in the denominator. All these m's are below my fraction bar. So wherever I have the larger number, that's where the exponent's going to end up being. So m to the 11th and m to the 15th, my larger number is in the denominator, so I'm going to subtract them, and I'll get m to the 4th. So you can sort of use a familiar situation, use some smaller numbers to sort of teach yourself, rather than memorizing some rules, because you guys can spend time memorizing. I'd rather you to truly understand, though. So, now let's apply that. 3x to the 6th, y to the 7th, over 27x squared, y. I would recommend breaking this up into some manageable fractions that you're more comfortable looking at. And just zoom in one at a time. So first, let's look at 3 over 27. That's going to simplify to 1/9. Now let's look at x to the 6th over x squared. So whichever has the greater value, that's where my number is going to end up. So I'm going to subtract them. The difference is 4. And because this is the greater value, I'm going to have x to the 4th in the numerator. And then y to the 7th over y, well, that's that makes sense. I could just have y to the 6th over 1. So I end up getting x to the 4th, y to the 6th over 9. Now, could you have done that just sort of canceling within? Yeah, totally. I recommend canceling your x squared and just writing this in as a 4, canceling this y out completely and just writing this in as a 6. So you have a 9 in the denominator, an x to the 4th, and a y to the 6th. There you go. So looking at this, let's look at my common factors for negative 28 and 12. I'll divide both by a 4. I'll get negative 7 and a 3. W to the 12th over W to the 9th. I'm going to totally cancel my lesser value, or my lesser power, and I'm going to cancel out just my power, and I'm going to write the difference. 12 minus 9 is 3. X cubed over x, I'm going to cancel out the value with the lesser power, and I'm just going to reduce this one by 1. So I have negative 7w cubed x squared over 3. Now, depending which technique you like, maybe you like writing it out, maybe you like doing it all with these tiny little details here, but that's your choice. All right, we have w cubed raised to the 5th power over w to the 10th. All right, first I need to figure out how to simplify this. Now, I remember my law of exponents, x to the a to the b is x to the ab. That's different than x to the a times x to the b, which is x to the a plus b. So I'm going to really have w to the 15th over w to the 10th. And my greater value, my greater power, is in the numerator, so that's where my value is going to end up. And so I'm going to take this difference between 15 and 10, and I'll get w to the 5th. And you can just write that w to the 5th. All right, looking at this, x plus 6 squared over x plus 6. So another way to think of this is writing it all out. It's just like some bigger chunks, so I'm going to cancel and cancel. Or I could cancel this one and then take this away and put 1. Either way, my simplified value is x plus 6. Now I would want to mention that the restriction is x cannot equal negative 6. All right, and then we have a plus 9 over 9 plus a. There's no exponents here. I'm tempted to cancel, but I'm going to stop myself because I know this is addition. So just because this is addition, maybe I can't simplify, but wait, a plus 9 over 9 plus a. 9 plus a can also be written as a plus 9, and that's just exactly the same thing, like 7 over 7, 12 over 12, so this is equal to 1. And you guys are going to encounter some interesting ones as I try to explore this with you a little further. So a plus 9 over 9 plus a, we now know just equals 1. What about a minus 9 over 9 minus a? Let's explore that by plugging in some values. What if a was 1? We'd have 1 minus 9 over 9 minus 1. So we get a negative 8 over an 8, so we'd get negative 1. Weird, okay. What if a was 10? So we'd have 10 minus 9 over 9 minus 10, so we'd have a 1 over a negative 1, so we'd have negative 1. Oh. Why am I feeling like this is going to simplify to negative 1 all the time? How can I prove that in a different way? So a minus 9, what if I factor out a negative 1 from this? So then I'd have a negative 9 plus an a, right? Because if I took the negative 1, I'd get a 9, and then if I distributed it here, I'd have a negative a. Okay, so now if I rewrote this, if I use the commutative property for this value right here, I could rewrite that as a minus 9, or a plus a negative 9. Oh, so now I can cancel that. That becomes 1 over negative 1. Okay, so this will always be a negative 1. And what that means is whenever you see an x minus y over y minus x, 7 minus 6 over 6 minus 7. A minus B over B minus A. 7 minus X over X minus 7. Subtraction and changing the order, it's always going to be equal to a negative 1. If you're not certain, test some values or look into factoring out a negative 1 and seeing if you then can cancel. So let's put some of those tricks to the test, and we're going to look at our homework 1 again. And we only have to do a few of these, number 8 and 9, that's it. So looking at m cubed over m squared, you'd cancel these, they'd be all gone, and this would just be a 1, so you just have m. X cubed over x to the 12th, my variable is going to end up being wherever the exponent is highest, so it'll be in the denominator, so I have 1 over, and then I take the difference. 12 minus 3, x to the 9th. All right, now, let's continue on to looking at factoring. So simplifying rational algebraic expressions by factoring. So what that's going to look like is I'm going to want to factor these expressions to see if there's anything in common. And by factoring, I'm changing them into products, so that inclines me to think that I'm going to be able to cancel because I'm changing things into products. So this first one is a dots. And this next one, I need to figure out how to factor this. So I need a positive 4, because this is a positive value, a negative 1, and let me just check by foiling. X squared, negative 1x, plus 4x, cool, and then I get a negative 4. Okay, good, so I'm all set. Whoops. So now, let me look. What could cancel? Okay, my x plus 4, my x plus 4, that cancels. That's cool to do because they are products. So I would get x minus 4 over x minus 1. And that is the simplified version of this expression. I would want to specify, if the directions required it, that x cannot be equal to 1. Duh, it says it right there. I can figure that out by just looking at it. More importantly, specify that x is not allowed to be equal to negative 4. Let's take a look at this one. We'll factor the top, factor the bottom. Is that the right factorization? Because normally these things turn out to be able to cancel. But yeah, okay. So sometimes things don't cancel. So it is. The same way when you get 7/17ths or 8/15ths. Sometimes you can't simplify fractions. Same thing with rational algebraic expressions. Oh well, so can't be simplified. Big deal. All right, 2x minus 3, and then a negative 3 plus 2x. Okay, is this one of those deals we were just talking about where it's subtraction and it's backwards? Well, let me change everything to addition to the inverse and check it out. So this is 2x plus a negative 3, and then if I rearrange this, then I'd have 2x plus a, oh, negative 3. So this is just equal to 1. Okay, cool. All right, x plus 7 to the 4th. Over x squared plus 14x plus 49. Okay, well, can't do anything up here. I'm definitely not going to multiply it out. And, oh, hey, this is a PST, because when I take the square root of this and double it, I will get this term. Okay, so this is just x plus 7 squared, which means when I simplify this, I will get x plus 7 squared. I do need to specify, if the directions ask, that x cannot be equal to negative 7, because originally I had this perfect square trinomial in the denominator. It is not apparent here, but restrictions still apply because they are based on the original expression. All right, looking at this one. Weird. When in doubt, either substitute values or use distribution. Those are going to be your two tools here. So you could use distribution. Negative 1 times, let's see, I would pull out this negative and this negative, so times x plus y. Okay, over x plus y. Sweet, this is just equal to negative 1. Awesome. Could I have figured that out with just substituting values? So let's say x was 5 and y was 19. So negative 5 minus 19 over 5 plus 19, negative 24 over 24. Oh yeah, I get negative 1. Cool. So that simplifies. So notice these are two very valuable tools that you can use. And finally, oh, this is looking that, it's like subtraction and it's exactly reversed. This is going to be equal to negative 1. How do I know that? Well, let's put a negative 1 on here, and we would get negative 2x plus 3. Now, doesn't this really say negative 2x plus 3 if I rearrange the order in my denominator? Yeah. But this all happened because I put in a negative 1. Either, you could say I multiplied it in or I factored it out. So what that means is this is the original expression. These values cancel. My negative 1 is the simplification. So here's what's coming up. Remembering the difference of 2 cubes, simplifying with that. And then, how's multiplying going to work? Well, hey, good news is it's kind of fun, and it's kind of the same way that simplifying works. So I'm going to take x squared minus 36. I'll factor that. That's over 5x. I can't do anything with 5x or the 10x. Okay, now I'm looking at this. Can I factor anything? I see a GCF. Okay, so my x plus 6, x minus 6. I see an x plus 6, I see an x plus 6. And notice I'm canceling, sort of going across to take the whole chunk. 10x and a 5x. Oh, okay, so that, I'm going to divide that by 5x and divide this by 5x and just get a 2. So I will get, don't forget my a is hiding down here. So I'll have 2 times x minus 6 over a. If the directions ask for it, you would want to specify that x is not able to be equal to negative 6, because that would have made this a 0. And then if you want to be really thorough, you want to mention that a can't be equal to 0, but you know what? Any mathematician